All right, 1-1, variables and expressions. This section should be reviewed for everybody. It should be a nice, comfortable place to start in our Algebra 1 textbook. We're going to talk about a couple of things in this. We are going to talk about. Pick up your highlighter. Well, this is a good start. Let's try this again. There's my highlighter. Okay, we're going to talk about changing verbal expressions into algebraic expressions, and we're going to take algebraic expressions and change them into verbal expressions. So we're going to go both ways. What does that mean? That means we are going to, if I can get a pen here, we are going to take a verbal expression like a number -5 and write it as x minus 5. We'll change it into a verbal expression. And we're going to do the opposite thing. We might have a verbal expression, and we're going to change that into words. A number squared, etc. Okay? All right, why are we going to do this? Well, let's look at a real-world problem. Here is Cassie and her friends are at a baseball game. Stadium is running a promotion where hot dogs are 10 cents a piece. Suppose D represents the number of hot dogs Cassie and her friends eat. So then 0.10D represents the cost of all the hot dogs they eat. So if they eat 50 hot dogs, it'll be 0.1 times 50. If they eat 16 hot dogs, it'll be 0.116. All right, so we can figure that out. So that's why it's helpful. You have a real life situation and you actually have to write an expression so you can figure it out. All right, what I'd like you to do here, the vocabulary for this section, you've seen all of these terms before in pre-algebra, so that should feel comfortable. I'd like you to write the definition of each of these terms in your notes, and I'll be looking at these tomorrow or in your next class. If you don't know the definition, then look it up in your online glossary. Algebraic expression, variable, term, factor, product, power, exponent, base. You can turn the video off, go ahead and do this, and then when you're finished writing your definitions, start your video back up. All right. Algebraic expression, 2x plus 4. There is an algebraic expression. It has all the components of an algebraic expression. It has operations, right? It has a term. It has two terms. 2x and 4 are both the terms, and it has a variable x. All right? But make sure you understand that both 2x and 4 are both the terms. So terms are things that are doing whatever the operation tells them to do. The thing we looked at in these definitions was a power. A power is a number that's expressed by its exponents, by how many times the factors there are. So for instance, x to the nth power means a number to some unknown number. So it could be x to the 4th, it could be x to the 15th, it could be x to the 5,789. So n is what we don't know. And the way you would read this is x to the nth power. X to the nth power. All right. This term, this power, this number is represented in powers, and it has an exponent of 3, and its base happens to also be 3. 3 is the base is the factor. It tells me what my base number is, and the number up here in the corner, the exponent, tells me how many times that 3 is going to be multiplied. It's going to be multiplied 3 times 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. So 3 to the third is the same as number 27. Remember, when no exponent is shown, as in the case of this y here in the box, it is understood that the exponent is 1. Or, so this is the same as saying y to the first power. We just don't write the 1. We just know it's there. Okay? And for that matter, if you had a number like 7, that really means 7 to the first power. Okay, let's write a verbal expression. Write a verbal expression for each algebraic expression. All right, we have 3x to the 4th. So how do we say that in words? Well, I can start 3 times some number, and I'll abbreviate number like that, to its 4th. I should write up the 4th. 3 times some number to its 4th power. 3 times some number x, we don't know, 4th power. Or you could also, there are other ways you could word this. You could say a number to its 4th power times 3. Right? Okay. Let's look at the next one. Which says 5z squared plus 16. So we have a number squared times 5 added to 16. Okay? There's more than one way to write these, but what I want you to do is become even more comfortable. I know some of you, it's your least favorite thing to do is to try and put math into words, but we're going to try and do that. That's what this section is about. All right. So it's important to change verbal expressions into algebraic expressions, and that's what we're doing in the second part of this section of the chapter. Take a minute and make this chart for your notes. I want you to look at this chart shows you different ways to say different terms. So for instance, addition, how does that sound in a sentence? Sometimes it says more than, sometimes it's the sum, sometimes it's plus, increase by, and sometimes it's added to. Are there other ways you could say addition? Yes, but these are just a few of the more commonly used ways that we do that. Take a minute, write down this chart because I think it'll help you remember what each of them mean when you see them in a sentence. Again, pause the video, make your chart. When you're done making your chart, start the video back up. Okay, here we're going to write an algebraic expression for the verbal expression. So we have a number t more than 6, a number t that's more than 6. So a number t is our variable, and it's that much more than 6. So it would be 6 plus t. Like t is a variable, as some of you guys know, because it looks a lot like a plus sign. So try to be careful when you're writing that one, all right? How about 10 less than the product of 7 and x? Well, the product of a number we know is multiplied. And so how do we write the product of 7 and f? 7f, right? And we have a number that's 10 less than that. So it's 10 less than this product. That means minus 10. This is always the tricky one. It is not 10 minus 7f. It's not that. 10 minus 7f would be 10 minus the product of 7 and f. This is 10 less than. So it's on the other side. So be careful with that one. You have to listen very carefully to exactly what the words are telling you. All right, and the last one, 2/3 of the volume of V. So here we have the volume of V, and we need 2/3 of it. Well, how do we write 2/3, right? So 2/3 of V would look like this. That was easy enough. Okey-doke. Let's look at some real-world examples. Sports marketing. Mr. Martinez ordered 250 keychains printed with his athletic team's logo and 500 pencils printed with their web address. So write an algebraic expression that represents the cost of the total order. So for one thing, he ordered 250 keychains, right? We let K represent keychains, and he did 500 pencil orders. So like we let P be for the price of a pencil and K be for the price of the keychains. And here we have, and those two added together will represent the total cost of the order. So there we have an expression for that marketing problem. Let's try another one. He estimates that 1/8 of the people who order beverages also order pastries in their coffee shop. So B is going to be the people that order beverages, okay? It could be any letter, but let's just pick B. And she thinks that in addition, 1/8 of the people who order beverages also order pastries. So how would we represent the people that order pastries? 1/8 of the B, right? These are the people that order beverages. These are the people that order pastries, beverages and pastries. And if you wanted to think about how many that is altogether, you would say 1/8, which is the people who order the pastries, plus the people that order the beverages. All right, I'm going to enlarge this a little bit. There we go. That's a little easier to read. So these are your practice problems for tomorrow that we'll do at the beginning of class. There are 10 of them. They shouldn't take you very long at all, though, maybe just a few minutes. So go ahead and try these problems. We'll look at them in class, and I'll be looking for them in your notes when I check notes tomorrow. Good luck, guys.